Hello students, we continue with integration by partial fractions in this lecture. This table I have put for you just to remind you all what we did in the previous lecture. We studied certain formulae in the table. We have completed sums involving the first type of fraction, the second type also. Now today we are going to go through further forms of the fractions which are there, and we are going to convert them into partial forms like this. Okay, so we begin with exercise 5.6. In exercise 5.6, the first three sums we have already done. We come to the fourth sum now. The fourth question, as you can see, it involves this sum, that is the integral of x upon x minus 1 square into x plus 2 dx. Now over here we write like we did in the previous sum. We write let x upon x minus 1 square into x plus 2 is equal to a upon x minus 1 plus b upon x minus 1 square plus c upon x plus 2. As you can see from the table, it is of this form, that is the fourth one, this particular form. Okay, whereby we convert it this way. Okay, so coming back to the sum now. Now after writing this, we cross multiply. From the LHS we take the denominator and cross multiply like this. Therefore we get x is equal to a into x minus 1 square into x plus 2 upon x plus x minus 1. Same thing we do for b. And plus c also the same thing. Upon doing this, now we cancel out whatever is common in the numerator and denominator in each term, and therefore we get this particular value, that is a into x is equal to a into x minus 1 x plus 2 plus b into x plus 2 plus c into x minus 1 the whole square. After doing this, now we write let any one of the brackets as 0. So let's suppose the first bracket, let x minus 1 is equal to 0. Therefore we get x is equal to 1, and therefore wherever x is there we put 1 now. So 1 is equal to a into 1 minus 1 into 1 plus 2 plus b into 1 plus 2 plus c into 1 minus 1 the whole square. Now wherever 1 minus 1 is there we are going to get 0. So those terms are going to become 0 now. So therefore we get 1 is equal to 3b, or the value of b becomes 1 upon 3. Now we put the next bracket as 0. So let x plus 2 is equal to 0, and therefore x is equal to minus 2. And wherever x is there, now we put minus 2. So minus 2 is equal to a into minus 2 minus 1 into minus 2 plus 2 plus b into minus 2 plus 2 plus c into minus 2 minus 1 the whole square. Now in this case again minus 2 plus 2 is 0. So wherever though that term is there, the bracket, the term becomes 0 over there. Okay, so a and b go away. So we get minus 2 is equal to minus 2 minus 1 is minus 3, and minus 3 square over here is 9. So 9c. And therefore c is equal to minus 2 upon 9. So we got the value for a, for b and c I mean. We have to yet find the value for a. Now for a, what we do over here is, listen very carefully. The third bracket is not there over here. Only two brackets are there. So we let x is equal to any other value, any particular value except 1 and minus 2. So let's suppose x is equal to 0, and therefore in the equation wherever x is there we put 0. So we get 0 is equal to a into 0 minus 1 into 0 plus 2 plus b into 0 plus 2 plus c into 0 minus 2 minus 1 the whole square, that is. Okay, then we get 0 is equal to, now minus 0 minus 1 is minus 1, minus 1 into 2, that is minus 2a, b into 2, that is 2b, and c into 0 minus 1 is minus 1, but minus 1 square is 1. So we get plus c. Okay, now here nothing went away, but we remember that the value for b and c we already know. So therefore we get 0 is equal to minus 2a plus 2 into 1 upon 3, that is b is 1 upon 3, and c is minus 2 upon 9 this way. Therefore, we bring 2a on the LHS, so we get 2a minus 2a comes here and becomes 2a. 2a is equal to 2 upon 3 minus 2 upon 9. Now, upon equalizing the denominator by taking the LCM as 9, we get 4 minus 2 upon 9, which is, sorry, 6 minus 2 upon 9, because 3 2s are 6, it becomes, we multiply by 3, the first fraction. So 6 minus 2 upon 9, which is 4 upon 9. Okay. And then we get the value for a. Therefore, a becomes 2 upon 9. So thus we got the value for a, b and c. So our integral becomes the integral of a upon. It is the integral of a upon x minus 1. So we get 2 upon 9 upon x minus 1 plus b upon. Now b is 1 upon 3. So 1 upon 3 upon x minus 1 the whole square and plus c upon x plus 2. Now c is minus 2 upon 9. So we write minus 2 upon 9 upon x plus 2 dx. And therefore we get, therefore the integral now becomes, now we separate out the integral. So 2 upon 9, the integral of 1 upon x minus 1 dx plus 1 upon 3, the integral of 1 upon x minus 1 the whole square dx minus 2 upon 9 outside, the integral of 1 upon x plus 2 dx. Now we solve it this way, that is 2 upon 9 into the solution for 1 upon x minus 1 is actually log x minus 1. Okay, let us write one more step over here before solving it. Let me write the first term as it is plus 1 upon 3. Now the second term, just for the sake of solving, we can bring x minus 1 the whole square in the numerator. So it becomes x minus 1 raised to minus 2 dx. Okay, and the last term remains as it is. Now we can solve it. And so we are going to get, now 1 upon x is log x. The integral of 1 upon x, remember it is log x. So here you get 2 upon 9 into log x minus 1, because 1 upon x minus 1, the integral of it is log x minus 1. Those who have followed my previous lecture will know what I am talking about. Now here x minus 1 raised to minus 2. So we use the formula for x raised to n in integration. Okay, the integration of x raised to n is x raised to n plus 1 upon n plus 1. So we get over here x minus 1 raised to minus 2 plus 1, that is minus 1 upon again minus 2 plus 1, which becomes minus 1. I hope you remember that. Minus 2 upon 9, here it is 1 upon x plus 2. So log mod of x plus 2. Now that we have solved it, we can write c plus c over here. We can modify this by writing 2 upon 9 log x minus 1. Okay, 2 upon 9 common, log x minus 1 minus log x plus 2 together. Okay, and plus 1 upon 3. Okay, 1 upon 3, the c 1 upon 3. Now x minus 1 raised to minus 1 can go in the denominator. So we get 1 upon 3 x minus 1. Now into this minus 1, that minus 1 comes out over here. We can write the plus sign as a minus sign because of the minus 1. So minus becomes, it becomes, okay, this way. Now one more step to get the final answer which they have given behind in the textbook, that is 2 upon 9. You know that when logarithms, two logs are subtracted, we can combine them and write them one upon the other. So we get 2 upon 9 log mod of x minus 1 upon x plus 2 minus 1 upon 3 into x minus 1 plus c. So this becomes your final answer. Now as an assignment, what you can do is, I'll give you one more sum to be done. Just as practice, you can practice this sum and check whether you're getting the answer which I provide to you. Okay, so let us call this sum as say 4a. This will give you practice of the concept that is there. So I'll just write the question here for you. Okay, and the answer also. So you can compare your answer after solving it. Do solve it and practice this up. Now we go on to the fifth question. In the fifth question is very similar actually to the fourth one. I'm just helping you to do it because those of you who haven't yet understood the fourth one can at least understand the similar sum which has been given as the fifth question over here in our textbook. Okay, so the question is the integral of 3x minus 2 upon x plus 1 the whole square into x plus 3 dx. Okay, again we write over here, let we convert it into partial fractions like this. Let 3x minus 2 upon x plus 1 the whole square into x plus 3 is equal to a upon x plus 1 plus b upon x plus 1 the whole square plus c upon x plus 3 this way, and therefore we cross multiply. This time I'm just cutting short the step a bit. Okay, so over here we are getting a into, now a upon x plus 1. So when we cross multiply with x plus 1 the whole square into x plus 3, we get x plus 1 into x plus 3. You can go to the previous sum and see this step how it is done if you are confused then. Plus b into x plus 1 the whole square it is. So x plus 1 the whole square, when it is cross multiplied with the denominator, the term gets cancelled, so we get b into x plus 3. Same way, plus c into x plus 3 gets cancelled here, we get x plus 1 the whole square. This happens when we multiply the denominator, cross multiply with the denominator. Okay, now we put each bracket as 0. So let x plus 1 is equal to 0, and therefore we are having x is equal to minus 1, and therefore we get 3 into minus 1 minus 2 is equal to a into minus 1 plus 1 into minus 1 plus 3 plus b into minus 1 plus 3 plus c into minus 1 plus 1 the whole square. Now obviously the a term and the c term go away because they become 0, and thus we get this value, that is minus 3. 3 into minus 1 is minus 3. So minus 3 minus 2 is minus 5 is equal to 2b, because 3 minus 1 is 2 over here, 2b. And therefore b turns out as minus 2 upon 5. Okay, b turns out as minus 2 upon 5. Then in the next step, b turns out as minus 5 upon 2. It is the reverse way actually. It is minus 5 upon 2. Okay, then next we put the next bracket as 0. So let x plus 3 as 0. The second bracket is x plus 3. So x plus 3 is equal to 0. Therefore x is equal to minus 3. Okay, and therefore putting minus 3 in the terms, we get 3 into minus 3 plus 2, that is minus 2 I mean, is equal to, in this case, a into minus 3 plus 1 minus 3 plus 3 plus b into minus 3 plus 3 plus c into minus 3 plus 1 the whole square. So in this case a and b go away, so that we get minus 9 minus 2, that is minus 11 is equal to c into minus 3 plus 1 is minus 2. In this case minus 2 square is 4, so 4c, and therefore c turns out as minus 11 upon 4. Okay, so c turns out as minus 11 upon 4. Just like the previous sum, let us put x as any value. Say let x is equal to 0 in order to find a here now. So therefore we get 3 into 0 minus 2 is equal to a into 0 plus 1 into 0 plus 3 plus b into 0 plus 3 plus c into 0 plus 1 the whole square. So now we are going to get 3 into 0 is 0. So we get minus 2 is equal to a into, now 1 into 3, that is 3a. Okay, 3a plus 3b plus c is what we are getting. So we substitute the values for b and c. So 3a plus 3 into, now the value for B was actually minus 5 by 2. So B into B, 3 into minus 5 by 2 plus C is minus 11 upon 4. So let us write minus over here instead of plus. So minus 11 upon 4. So minus 2 is equal to 3A. Now minus 15 upon 2 minus 11 upon 4. Bringing all the terms on one side, taking 3A on the other side, or rather writing this way. So 3A is equal to minus 2 plus 15 upon 2 plus 11 upon 4. Okay, now here 4 is the LCM. So we equalize the denominator by taking 4 as the LCM. So cross multiplying and getting the answer here. So minus 8 plus 30 plus 11 upon 4 we get, which comes out as actually 33. 33 upon 4, which is 3A. Okay, 33 upon 4. And therefore A becomes 33 upon 4 into 3, which becomes 11 upon 4. So now that you've got A, B and C values, we'll substitute these values over here. So therefore our integral, therefore I is equal to the integral of A upon x plus 1. Now A is 11 upon 4 upon x plus 1 dx. Okay, instead of writing dx, let us write dx in the next step. Let us see how to do. Okay, and B is minus 5 upon 2. So minus 5 upon 2 upon x plus 1 the whole square. And since C is minus 11 upon 4, we get minus 11 upon 4 upon x plus 1, x plus 3 at this. Okay, dx. Now you are going to solve this sum, complete the sum as assignment, refer to the previous sum, try to get the answer in that way. Same steps are there. So solve the sum and check your answer out from the textbook. So complete this sum now. Now the sixth sum, pay attention to the sixth sum. It is a bit different from the other sums which you have done so far. The question is integral of 1 upon x into x raised to 5 plus 1. Obviously here we cannot go further without substituting. So look carefully at the next step that is being done. So we write it this way. The integral of, suppose we want to write x in the denominator, this x in the denominator, suppose we want to make it as x raised to 5. Then in the numerator we should have x raised to 4. Only then can we get x raised to 5 in the denominator. So we write it this way. For the sake of substitution we are doing this. Okay, so x is converted into x raised to 5 in the denominator, and then in the numerator we get x raised to 4. Okay, and into x raised to 5 plus 1 dx. Now here we substitute this way. Let x raised to 5 is equal to t. Therefore, upon differentiating on both the sides with respect to x, we get 5x raised to 4 dx as dt. Okay, remember substitution sums you have done earlier also. And therefore, x raised to 4 dx becomes dt upon 5. Okay. Now, as you can see over here, our numerator itself is x raised to 4 dx. So, we can substitute that x raised to 4 dx as dt upon 5. And therefore, our integral upon substitution, it becomes dt upon 5 upon, now x raised to 5 is t, we substituted it over here. So, t into t plus 1. Okay, so this is how our integral becomes. Now, we take 1 upon 5 common from the integral, so that we get dt upon t into t plus 1. Okay, so dt upon t into t plus 1 we are getting. Now, just like we did earlier, okay, we are going to write let 1 upon t into t plus 1. We are converting it into partial fractions. Let 1 upon t into t plus 1 is equal to a upon t plus b upon t plus 1. The first form of partial fraction it becomes. Okay, so that now cross multiplying again, we get therefore 1 is equal to a into t plus 1 upon t plus b into again the same thing. Okay, then we cancel out t over here and t plus 1 from here. So that we get 1 is equal to a into t plus 1 plus b into t. Then in the next step, we put any one of these values as 0. Say let t is equal to 0, and therefore we are going to get 1 is equal to a into 0 plus 1 plus b into 0. Obviously this goes away. So therefore we get a is equal to 1. So the value of a we obtained as 1. In the same way, we put the next term as 0. Let t plus 1 as 0, and therefore t becomes minus 1, and therefore we get 1 is equal to a into minus 1 plus 1 plus b into minus 1. Now here a goes away, and therefore we get b is equal to minus 1. So thus we get the value for a and b. So now our integral is modified. Therefore our integral is actually a upon t. So a being 1, 1 upon t, and b being minus 1, 1 upon t plus 1. b upon t plus 1 becomes minus 1 upon t plus 1 and dt in this case. Okay, then in the next step, okay, we just substitute, that is in our integral, if you remember, we had 1 upon phi as well. Outside the integral sign over here, we had 1 upon phi as well. Okay, so we put that also outside the integral sign, and thus now we are in a position to solve the sum. Or we can separate the integrals this way: 1 upon phi integral 1 upon t dt minus 1 upon phi again the integral of 1 upon t plus 1 dt. You know that the integral of 1 upon x is log x. So here we get 1 upon phi log t minus 1 upon phi log of t plus 1 and plus c. Okay, now we resubstitute because t was actually x raised to phi. Okay, we can first of all combine these logs and write this way. So 1 upon phi is common. We can combine both the logs. Since there is a minus sign, we get t upon t plus 1 plus c, which becomes 1 upon phi log of mod of x raised to phi upon x raised to phi plus 1 plus c. So thus we get the answer over here. Okay, now we go on to a very similar sum. The next sum, as you can see, it is very similar to the previous sum. Okay, 1 upon x into x raised to n plus 1 dx. Now in the previous sum, when we got 1 upon x into x raised to phi plus 1 dx, we got in the numerator as x raised to 4, isn't it? We put x raised to 4 in the numerator, and in the denominator x became x raised to 5. Okay, now in this case we are going to write like this, that is, we want x raised to n over here in the denominator. Okay, this term, x term, has to become x raised to n. So in the numerator we have to write x raised to n minus 1. The same way how we wrote x raised to 4 upon x raised to 5. Here we are writing x raised to n minus 1 upon x raised to n dx. Okay, now we put x raised to n as t, and therefore upon differentiation, this is the formula for x raised to n. So we get n into x raised to n minus 1 dx as dt, and therefore x raised to n minus 1 dx becomes dt upon n. Okay, so same, the numerator becomes x raised to n minus 1 dx, and that becomes dt upon n. Therefore our integral becomes now dt upon n the whole upon t into t plus 1. Okay, which becomes 1 upon n the integral of dt upon t into t plus 1. Now some of the steps you are going to write it yourself. It is just like the previous sum. When we write, see, when we write 1 upon, so we write let 1 upon t into t plus 1 is equal to a upon t plus b upon t plus 1. Okay, like the previous sum. Okay, we get a as, now you can solve it just like the previous sum. Okay, a as 1 and b as minus 1. You have to solve it and show the steps. In the exam time, you cannot just write this step and keep it as it is. You have to solve this step. Okay, then our integral now becomes I is equal to 1 upon n, the integral of a upon t, that is 1 upon t, minus b upon t plus 1, that is b is minus 1 and therefore minus 1 upon t plus 1 dt. Again, the next step is same like the previous sum. So we are getting 1 upon n common. Let us take it common. Log t, I have cut the sum short a bit. So log t minus log of t plus 1 dt. T plus 1 plus c, I mean not dt but plus c. Now here combining both these logs, 1 upon n log of t upon t plus 1. And t is nothing but x raised to n. And therefore 1 upon n log of x raised to n upon x raised to n plus 1 plus c. So this is how the sum is completed. Now here I wish to give you a homework actually. I wish to give you an assignment over here. Try out this particular sum. That is, it is the integral of c. Let us mark it as 7a just to practice this sum. Okay, try out this sum. The integral of 1 upon x into x raised to say 6 plus 1 dx. Yes, you have to do it in the same way like the 6th sum. So by now those who have been paying attention will be knowing how to do it and you will get a very similar answer. You can get it for yourself. If there is any doubt, you can always ask me for guidance. Okay, so we go on to the next sum, the 8th one. Okay, the 8th one is the integral of 5x square plus 20x plus 6 upon x cube plus 2x square plus x. Now, in this case, what we do is we take in the denominator, suppose we observe the sum properly. We see that in the denominator, x can be taken common. Isn't it? All the three terms have x over here. So, our integral can be written this way. Now, taking x common, in the bracket we get x square plus 2x plus 1 dx. Now, we see that this can become this is a quadratic equation. It can be solved by splitting the middle term. And so, we get here 5x square plus 20x plus 6 upon x into, now when we solve it, we are going to get x plus 1 the whole square. You can solve it and see it for yourself by splitting the middle term. You will get x plus 1 the whole square. Now, which form is this? Yes, it is of a sum which we have done earlier. We write over here like this now. 5x square plus 20x plus 6. That is, let this term, the whole term, that is, be a upon x plus 1 plus b upon x plus 1 the whole square, yes, like the fourth sum, okay, plus c upon x. Now we proceed to find the values for a, b and c, okay. So by cross multiplying we get 5x square plus 20x plus 6 is equal to a into x plus 1 the whole square upon x plus 1. We do it similarly for b and c also. We cross multiply over here. Okay, then we cancel out whichever terms are common in the numerator and the denominator for each expression that is there. And thus we get this particular term. Okay, we get 5x square plus 20x plus 6 is equal to ax into x plus 1 plus bx plus c into x plus 1 the whole square. Okay, then in this case we put each term as 0. So first let x is equal to 0 and therefore we are going to get 5 into 0 square plus 20 into 0 plus 6 is equal to a into 0, 0 plus 1 plus b into 0 plus c into 0 plus 1 the whole square. Okay, so here A and B get cancelled because they become 0 and we get 6 is equal to C. So C becomes 6 over here. Okay, we get the value of C as 6. Then in the next step, now let x plus 1 is equal to 0. The next term, that is x plus 1 is equal to 0 and therefore x is equal to minus 1. And therefore putting minus 1 over here, we get 5 into minus 1 the whole square plus 20 into minus 1 plus 6 is equal to a into minus 1 plus 1 plus b into minus 1 plus c into minus 1 plus 1 the whole square. Wherever minus 1 plus 1 is there, the term becomes 0. So a and c terms go away and therefore we get 5 minus 20 plus 6 is equal to minus b, or minus 20 plus 11 gives us minus 9, which is minus b, and therefore we get the value for b as 9. Now we still haven't got a, so we substitute x as any other value other than 0 or minus 1. So suppose x is equal to 1, it can be any value. Suppose x is 1, therefore we get 5 into 1 square plus 20 into 1 plus 6 is equal to these terms, that is then in the next step we get 5 plus 20 plus 6 is equal to, now 1 plus 1 is 2, so 2a plus b plus 4c, and therefore 31 becomes 2a plus b, the value for b is 9 plus the value for c is 6, which we got earlier. So this becomes 4 6 are 24 and therefore 2a is equal to 31 minus 33. Okay, and therefore a becomes minus 1. So in this way we got the value for a, b and c, and therefore our integral becomes I is equal to the integral of a upon x. It was a upon, let me see it. Okay, a upon x plus 1. Now our a in this case is minus 1. So we get minus 1 upon x plus 1 plus b upon x plus 1 the whole square. Now the value for b is 9. So 9 upon x plus 1 the whole square, and the value for c, which is 6. So 6 upon x dx. Okay, so this becomes our integral. Then going further, we get minus 1, the integral of 1 upon x plus 1 dx, plus 9 the integral of, now we bring x plus 1 the whole square to the numerator, so it becomes x plus 1 raised to minus 2. This step we already know because you have observed the earlier sum. Okay, plus 6 the integral of 1 upon x dx, which now gives us the answer, that is 1 upon x, the integral of 1 upon x is log x. Once again I am telling you. So we get minus log x plus 1 plus 9, we use the formula x raised to n over here. So 9 x plus 1 raised to minus 2 plus 1 gives us minus 1 upon minus 1, and plus 6 log of x and plus c. Okay, so in this case we get 6 log x, the answer becomes 6 log x plus, or we can write over here minus 9 minus log x plus 1 first, and minus 9 upon x plus 1, and this becomes our answer for the sum. So thus we complete exercise 5.6. This was the last sum of the exercise, but we have not yet completed partial fractions because we are yet to go through miscellaneous exercise 5 and check out which sums there are given dealing with partial fractions. But that will be for the next lecture. Thank you so much for being with me throughout the lecture. We meet in the next lecture. Keep practicing. Make this concept thorough by the next time. Okay. Bye students.